Hi, class. I just wanted to give you a, a brief introduction to Module 3. Module 3 is on probability, and, I guess what I would like you to know, although we might not study this in depth, is, why are we studying probability in statistics class? And typically those two things are taught together. A lot of times they are. When I was in college, that was the name of the course, Probability and Statistics. And the reason is because probability is used a lot in statistics, in the methods. And it stemmed from the fact, once again, remember, what is statistics about? Well, we cannot find, we can't collect all the data of a population. We just can't do that. It's not practical. It's very time consuming and intensive labor is involved, or resources and money. We can't afford it. So we have to take a sample. And then from the sample, we make inferences, right? So the question is, if I take another sample, I'm only going to take one. But if I took another one, I would get different numbers, right? I would get a different number for the average and for the standard deviation of that sample, right? They're not going to line up. And that's a problem. It's called sampling error. So what do we do? Well, that's why we study probability. Essentially, I guess, what I want you to think about is what you do when you take a sample and you make inferences. You ask yourself, what's the likelihood that I got the sample that I did? All right, and that's kind of the theory behind probability. What's the likelihood that I will get the particular the sample that I got? And you kind of use that to give some level of confidence to your inferences. All right, I hope that makes sense. You take a sample. If you take another sample, you're going to get a different number. So we need to know the probability of getting a particular sample and how close that might be to the true value. And that's why we're doing this. So anyway, let me just review a few things here. Let's see. That didn't work out. Hang on. Okay, so I just made just a few basic concepts of probabilities, a sample space, right? That's a set of all possible outcomes. All right, so if we roll two dice, these are all the possible outcomes, all right? The first one would be a 1, and the second one could be a 6. Or the first one could be a 1, and the second one a 4. The first one could be a 4, and the second one a 3. These are all the possibilities, all the possible outcomes, okay? And that's called the sample space. And then an event is a subset of that. And you define the event. It's what you're interested in. What's the likelihood that I get doubles? All right. So that would be the event, getting a double. And it would be this diagonal here. There's the 1, 1, 2, 2. That's a subset. And depending on how big the subset is, that determines the probability that one of these outcomes will happen. All right? So if I said, what's the probability that the first die will be a 1, 2, or 3? I'd look at my sample space and I'd say, well, that would be this section right here. And so that would be half of it, 50% likely, right? That's the idea of sample space and event. And basically the book goes into 3 types of probabilities. What we just talked about is the classical one, where you pick an event A and you count the number of outcomes in A, assuming that they're all equally likely. And then you divide it by the total, right? So if we said, we would count the number here of getting 1, 2, or 3 on the first die. We would count those up, and then we would count all of them and come up with a fraction or percentage, and that would give us the probability. Okay, a couple things I wanted to point out, which, you know, when I was growing up, we played cards and 52 pickup. We all knew the suits and all that. I don't know if you do that anymore, but just as a reminder, there's 52 cards in a deck. All right, so what's the likelihood, for example, that I pick the 4 of clubs? That's one card out of a possible 52, so 1 over 52. All right, and also know there's 4 suits: hearts, diamonds, clubs, spades, and there's 13 of each of those. So what's the likelihood that I pick a heart? Well, it's going to be 13 over 52. So I want you to be familiar with those numbers, because that's typically how the test will ask you about probabilities. And you know there's 6 sides to a die. That's another typical problem with classical probability. The other type of probability is empirical. And that means we don't have this scenario where we know that each space. And just for example, how many students like math at the college, right? Well, how would we find that out? We would find out experimentally. We could give a large number of students a survey, and then just calculate how many of them like math. Maybe 30, for like here it says, survey found that 34% of students love math. I hope it's higher than that. But, and then I could say, well, what's the likelihood, what's the probability that I pick a random student and they love math? Well, the probability that I found from my survey is that it's 34%, okay? The last one is subjective, and that just is like the medical field. Over history, they've seen things, and the doctor might say, oh, from what I've seen, this is 20% likely to be poison ivy or something like that. Or you have a 45% survival rate, all right? So that's kind of subjective based on expertise in history, okay? Then the last thing I wanted to tell you about probability, which I kind of love this part of human development. It turns out that 2 men in the 1600s, Blaise Pascal and Pierre Fermat, wrote letters back and forth. They were both mathematicians, and they came up with probability theory over a problem called the problem of the points. All right, and I think it was about gambling, which has been around forever, you know. But for someone to really study it mathematically, and the interesting thing on that was they learned to think of things in the future, and that was entirely new. Nobody, like back in the day, people would not think of things in the future and calculating things in the future, and they kind of broke through that. And now, of course, you know, our insurance companies, all those kind of actuaries, they think, well, what's the likelihood of this person at this age to have a car wreck? All that probability theory. And it allows us to really make some good judgments financially, economically, and otherwise. So anyway, I love that stuff. Check these guides out. Type in problem of the points if you want and look that up, and you'll learn about these two. I hope that gives you an overview of Module 3. That's the probability section, which is really just the beginning. And I'll try to add some more videos or help for the rest of the section. All right.